Welcome back to Applied Algebra. This is Rebecca Snyder, and today we will be working on multiplication of monomials. So in the last section we talked about monomials, and if you can remember, monomial means one term. This lesson we'll be taking single terms and multiplying them together. We'll be finding their product, we'll be taking them to a power as in example 2, and then we'll be plugging in some terms and solving for them, or simplifying I should say. So to begin with, we'll take the product of two of them. When we are multiplying, you just put like terms together. So we're going to do negative 42 times negative 0.5. Negative times a negative is a positive. Half of 42 is 21. When we go to put the variables together, we have to put like ones, so the A's are going with the A's. And what this is saying is I have a single A, I'm multiplying it with 3 more A's, that's what a to the third is. As you can see, I now have 4 A's, so this becomes a to the fourth. There are no other B's except for this B at the end, so it's just a single B. So the product of negative 42A times negative 0.5A cubed, B is 21A to the fourth B. If you happen to have more than just 2 terms that you're multiplying, it's okay. Just do 2 at a time, or you can try and do all 3 or more. So again, you're going to go ahead and put like terms multiplying together. So we're going to go 5 times negative 17 times 3. Let's go ahead and multiply that out. 5 times negative 17 times 3 is negative 255. We'll go ahead and look at the variables now. I have an a to the first, a to the second, a to the third. So I have a to the second, a to the third. 1, 2, 3, 4, 5. I have 6 A's. What you might be noticing is that what we're really just doing is adding the exponents, so it's 3 plus 2 plus 1, which is 6. So you don't necessarily have to write it out like I've been doing, so you can see it visually. I have a variable of B, but the only one I have is back here in this last term, so it's just going to be B. If I had more than one B, I would put them together just like I did the A's. In example 2, it's a little bit different. Instead of multiplying monomials out, I have a single monomial and it's to the fourth power. Powers, remember, are saying you have that term multiple times. So this one in A is saying I have 4 of these that I'm multiplying out. But I didn't want to really write it 4 times. So instead what we're going to do is take it to a power. We're going to multiply. So on this one, I'm going to go ahead and separate it out. I have negative 4 to the fourth, I have a squared to the fourth, b to the third to the fourth, c to the fourth to the fourth. All of those individual, they're not terms because this is a single monomial, all of the individual parts to this term have to be taken to the fourth power. Negative 4 to the fourth is 256, so that is saying do negative 4 times negative 4 times negative 4 times negative 4. I get 256. This one is saying take a to the second times a to the second times a to the second times a to the second. Well, if I were to write all those out, I'd have 2, 2, 2, and 2. 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 2 is 8. So I essentially have 8 A's. Well, I can get that also by just multiplying the exponents. So 2 times 4 is 8. So I have a to the 8th. I do the same thing with the B's. 3 times 4 is 12. Same thing with the C's. 4 times 4 is 16. So these are little shortcuts that are allowing us not to have to write it out like I've done up here in this top corner. If I move on to example 2b, I'm going to go ahead and multiply this inside, x to the second times x to the cubed, as if it was in product, as in examples 1. I have 2 x's, I have 3 x's, so altogether I have 5 x's on the inside. Because that's a 1, 2, 3, 4. So there's my x to the second, there's my x to the third. I can see there's now 5 of those. This is saying I have 2 x to the fifths, so x to the fifth and x to the fifth. I can do the shortcut where I just multiply the exponents instead of having to write it all out. So I have 2 groups of 5, which I have 10 x's. In example 3, what they're asking us to do is go ahead and combine our expressions as we've done in example 1 and 2, but then combine, or not combine, then put in a 2 for the a's and negative 3 for the b's. So we have 9 times the invisible 1 to start with. I have a to the first and a to the first, so I have a to the second. I only have b to the second in the second term, so it's going to stay the same. We're now going to go ahead and plug in 2 for the a and negative 3 for the b. 2 squared, negative 3 squared. If I follow my order of operations, two squared is 4, because I'm going to do exponents. Negative 3 squared is 9. 9 times 4 is 36. So I'm doing multiplication from left to right. 36 times 9. The answer to this is 324. If they are asking you to plug numbers in for the letters, you should end up with a result that is just numbers. On this one, we're going to go ahead and do the same process as example 2. I have negative 2 to the second, a to the second, b to the second to the second. Negative 2 to the second is 4. Using the shortcut, I know it's just 1 times 2, so that's a to the second. 2 times 2, so that's b to the fourth. Now you might want to be done, but don't. We have to plug in the a and the b. So be careful when you're doing that part of your assignment that you make sure you plug in for the letters. The a is 2. The b is negative 3. 2 squared is 4. Negative 3 to the fourth is 81. 4 times 4 is 16. 16 times 81, 1,296. So again, my letters are all gone now because I've replaced them with numbers. If you have any questions when you're working through section 5.4, please go ahead and email me so I can answer them. Thank you and have a good day.